So what is network diffusion? So network diffusion is nothing but it captures the underlying mechanism of how events are interpropagated throughout a complex network. It is nothing but spreading of your network. For example, if you see in LinkedIn, so we will be, when creating an account, we will be the single user. But when we try to grow our networks with the connecting with the CEOs or with any other, we'll be connecting with the team leads or with the working professionals, teachers, faculties, each and every member. That is how we'll be going to spread our network. That is nothing but the network diffusion. So what we'll be doing, we'll be diffusing, that nothing but we'll be spreading out our network, and which we'll be showing our achievements, all those things. So what is network diffusion? So network diffusion, so the network diffusion captures the underlying mechanism of how events slash info propagate throughout the complex network. So in the very real time network, which is the best way to diffuse. For example, if you consider the TikTok makers, so they will be diffusing their videos to each and every person in the world. So they will be getting more famous than the one who are not making the TikTok videos. So this is a one quite good example of network diffusion, complex network. So or it is a statistical tool to detect and quality social transmission of information or behavior of social networking. Or you can also make a note of this also. So this is another definition of network diffusion. So it's a statistical tool to detect and quality social transmission of information or a behavior of social networking, or a behavior of social network. So let me illustrate with an example. So can see once you so when you create a Facebook account, you will be the only one user. But later we'll be sending your friend request to each and every members you see in your friend request. So friends of friends, friends of friends, friends of friends. So this is how we will be making within a 1 month. You will be having a 300 to 400 friends. So you are making your network to grow in Facebook. So for example, let us take a scenario in class. So if one person write an assignment, what will the remaining do? So remaining will be trying to copy copying the assignment from the person who have written. So this is also called as network diffusion. So he is sharing his assignment to each and every node. So node is nothing but the persons. So once if you see the virus, what will happen? So virus starts in somewhere at the world, and what will happen? It will spread like corona. So basic example is corona, Ebola are the basic examples. So what will happen? They will be born at a certain place, but they will be diffusing to the entire world. For example, there is a saying that good will not reach uh, fake news will reach faster than the good news. So this is one of the examples of network diffusion. For example, if you share any rumor to your friends, within a fraction of seconds the rumor will be spreading to the thousand members. So that is what network diffusion deals with. So there is a one simple mathematical explanation for network diffusion. Consider this as a and b as a different communities, and there is a and we need to select n properties from a different communities. So let me explain this mathematical theory using an example. So if consider a as an apple, apple, and b as a ball, so they are n people. So it is the choice of n people to decide whether to choose apple or whether to choose ball. So some of them choose apple and some of them choose ball. If the number of people choose ar, n people have chosen n people have chosen apple, so the number of remaining people will be 1 minus n, or n minus 1 people will be remaining who have chosen the ball. So don't get confused. Let me take it as, so number of people choose apple are, let me take it as p. So the number of people will be remaining is n minus p will be choosing b ball. So if a has a payoff of a, small a, and b has a payoff of small b, so what is the overall payoff, overall payoff of the person choosing the apple is, so payoff is nothing but the p into a. So this is the payoff of the people who will be choosing apple. And what is the payoff of b? Payoff is nothing but the probability of choosing. So what is the payoff of b? Payoff of b is n minus p into b. So this is a probability. So we have to check whether these two, because as we are dealing with the number of persons, so there may be a chance of there are equal number of people who will be choosing apple as well as ball. If, for example, if there are 6 people, 3 can choose the apple, or 3 can choose ball. So we'll let me try to do it. So it is an np greater than or equal to what will happen, n minus p into b. So if you need to calculate the p value, or if you need to calculate a value or n value, we can just try to move left or sideways. So this is a one mathematical representation of network diffusion. So there is one other concept called social reinforcement. What social reinforcement means? Social reinforcement. What is social reinforcement means? I will explain within a small problem. So you are the one here, and your friend of one will say that hello bye, let's chalo baar chalenge. But what will happen? You will be insisting him that I will not come. Another guy will be coming and will be asking you, will be shall we go out? But you will be say that you will insist that I will not come out. But another person will come and say that come on bro, let's go out. But you will also insist. But if another person come, you will feel that so all the people are going outside, so let me also move out. So this is called social reinforcement. By without insisting, because based upon your external characteristics or external forces, you will tend to move on with them. So because a came, b came, c came, d came and told you that let's go out, but you for the 3 choices you told that I will not come. But what happened when the fourth one came out, when D has reached you, so you thought that everyone is going out, so you also will be going out. So that is called social reinforcement. For any particular time or particular force happens on you, you will be not able to decide which one is the correct one and which one is the false one. So that is called social reinforcement. So this is what also happening. This is what also called as network diffusion, because we are diffusing with the network characteristics. So let us move to the parameters of diffusion. So there are 4 properties of network diffusion. How a network is diffused into the market or worldwide. So there are 4 types of network diffusions. One is strategically we can grow ourselves. One is infectious. There are 4 types. I will explain it. So there are 4 types of diffusion. That is infectionist, infectionist, and second one is resistance, and third one is topology, and the fourth one is strategy. So let's speak about one by one now. So infectious, infectionist. So what is infectionist? It is nothing but the spread or influence other in a rapid manner. For example, if you take a mosquito, what will happen? Does it feel that it is does it so let us take a mosquito. What will happen if the mosquito bites? So it will be spreading malaria or dengue, anything. So but the mosquito doesn't know that it is spreading malaria. That is what infectious. Without our involvement, everything will be happening. That is what infectious is. Irrespective of the type of network, that's something that is likely to spread over the network in a rapid manner. So the best example is corona. So it is started somewhere in China, but it has reached all over the world in a rapid manner. So that is one of the characteristics of infectious. So let me write it. So type of it is which is likely to spread or influence other in a rapid manner. So this is what is called. Coming to the network technology, network social networking, we'll be seeing that irrespective irrespective of the type of network, that something that is likely to spread over the network in a rapid manner. So there is a huge problem for in this infectious MANR. We don't know in that how it will be spreading out. So for example, consider the where case where glaciers have burst out. So the in Uttar Pradesh or Uttarakhand, so that it will be spreading out within a fraction of seconds to the entire world. That is what infectious. So let's just move to the another one, another parameter, that is resistance. So without resistance or without anything, we can't survive in this world. That is, it means that capturing how nodes may be affected or for a brief period of time before recovery. Basic theory is Darwin's theory, that is fittest of the survival. Without resistance, we can't do anything. So like that, only in every nodes or in every connections, we have to make sure that we will be restricting throughout the network. For example, if we take WhatsApp, if any person don't like the other person, what she or he will be doing, they will be blocking them. So here what will happen, you don't have resistance, you don't have particular resistance to stay and create your network. So resistance is very much important. So it means, when coming to the social networking, it means that capturing how nodes may be affected for a brief period of time interval. So that is what resistance is called. So let's just move to the another topic, that is known as another parameter, topology. So we already know that topology is nothing but layout of networks. So what will be happening? We'll be building a small community, right? We'll be staying in a small community, and we want to explore and we want to grow our network within a small community or with a small topology. The network topology may be in any of the diffusions may occur. So there are three basic topologies how a person can grow. So there will be a degree of connectivity, shortest average shortest path, degree distribution. We have already seen all those things, what is what and what is what. So they are degree of connectivity. So if you know two friends, you will be able to send your friend request or Instagram request or WhatsApp chat to there based on your number of friends. That is known as degree of connectivity. So how the nodes are connected to overall the network. So overall, on the overall network, you can send your request to each and every one. So that is how it is. So degree of connectivity deals with how the nodes are connected over the network. So second parameter is nothing but average shortest path. So what is the average shortest path means? I all told that to get an idea that how many edges are connected in order to affect the whole system. So we'll be doing, we'll be taking the each and every shortest path distance by total number of edges or edges we'll be having. That is what we'll be doing in previous sum. But what is happening if we take the shortest path medium, that is social media. For example, social media, how the TikTokers has made famous. So using the social media, that is the very shortest path to get very famous. Shortest path to get an idea that how many how many edges are connected in order to affect the whole system or whole network, whole system. So that is what it will be doing in shortest path. So we'll be finding a very shortest path reason to explore ourselves. So next one is the degree distribution. Degree distribution is nothing but the how centralized the network is. So we'll be sending our friend request or Instagram request, anything based upon the degree we have. That is, if I know 10 people, I can only send the request to the 10 people, and then when the mutual request will be coming, then you can expand as per your requirements. So degree distribution is nothing but how centralized the network is. So that is what degree distribution speaks about. So coming to the last parameter, that is strategy. So there are two types of strategies: random strategy as well as the uh, random strategy and strategy, that normal strategy. So this strategy is also called as dissemination strategy. So what we'll be doing in dissemination strategy is nothing but spreading something widely, especially information or anything that we'll be spreading out. So we need to know that the dissemination is random and static. So there are two types, that is, one is random and one is static. So we don't know that corona will be spreading this much, will be making this much of loss to the entire world. So corona is a random, what we'll saying, which is a random strategy of that disease. What is the strategy? What will be doing that? For example, if you want to propose to a girl, we'll be having up some sort of strategy, like we'll be meeting their friends or their family members, and we'll be making them sure that they will be fall to you. That is what something we'll be doing in strategy. So we'll be having some strategy plan. For example, if you want to clear any exam, any government exam, we will have a certain plan, that for example, how many hours I should prepare for, and what is the book should I follow, what are the resources which I use. So we'll be having a strategic planning to clear each and everything. That's all about strategy. So strategy dimension is nothing but spreading widely, especially information. So there are two types of I already told that there are two types, that is random strategy, and the second one is strategy itself. So dissemination strategy has two types: random strategy and strategy. So what does a random strategy deals about? It deals about the randomness, that it doesn't have any logical behind them, but it will be spreading so far that each and everyone will be knowing that each and every node will be connecting. So there is no logic behind it, but it will form networks. So while coming to the strategy, so we'll be having what we'll be having will be diffusions, some diffusions are strategic. That, for example, if we want to prepare and if we want to do anything, so there is some certain strategy to be followed. For example, in military, they choose the critical node that have a high degree connectivity to affect the whole network. For example, they want to affect the launch pads. What will be they doing is that they will be selecting the most important place, and they will try to place the rocket on. So that is one of the main example of military or your plan, anything. So that's all about the network diffusion what we have seen so far. So we have discussed the network diffusion. What is it? Network diffusion captures the underlying mechanism of how events or information propagates throughout a complex network. So then we have seen the mathematical representation of a network diffusion, that is, if we have calculated the payouts, and generally we have given a small mathematical representation. Then later we have discussed about the social reinforcement. Then we have moved to the parameters of diffusion. So there are four parameters: infectious, resistance, topology, dimensional, strategy. So what is infectious? Will be spreading without any we'll be spreading without any logic behind it. And what is resistance? We should have them resistance to stay in the competition. What is topology? Based upon the degree shortest path and the degree distribution, we'll be making a new connections. What is strategy? Strategy is again divided into two types: random strategy and strategy. In random strategy, there is no logic behind it, but we will be building a network so far so fastly. What is strategy? But in strategy, we'll be making a move based on our strategical and time consuming. So that's all about today. That's it. Thank you.